I spend most of my time messing around in coastal wetlands. And coastal wetlands are pretty varied, from those that are wet all the time, like seagrass meadows and the intertidal mudflats, through to those that are wet some of the time, but very salty, like the mangroves and the salt marshes. Then further inland again, there's areas that get the tide every now and then, but not very often, and get affected by rivers. You have your estuarine wetlands, the rushes, reed, sedge lands, which are further inland and are almost fresh. And right on the cusp between the land and the sea, you get the back barrier lagoons and the sabkas and salt pans. And these are really interesting because sabkas are basically nearly always dry, but sometimes wet. And lagoons are basically nearly always wet, but sometimes dry. And they vary from whether they're fresh all the time, perched up above the water, or whether they're quite salty. So north of Adelaide, where it's a bit drier, you tend to get sabkas. Even the artificial Buckland Park Lake is madly infilling and trying to turn into a sabka as we speak. But further south, where there's a bit more rain and where there's something that looks a bit more like rivers, then you get coastal lagoons. And here in Aldinga, you have a coastal lagoon. But even coastal lagoons are incredibly varied. They're not all the same. So this one here is fresh in winter and it dries out quite rapidly in summer. The basin's carpeted with salt marsh vegetation that can tolerate very long periods of inundation and even longer periods of being dry. But it's not necessarily the way it's always been. I wasn't here very long ago, so I can't tell you exactly what it was like, but I'd suspect that it may have been holding water these days for less time, partly because we cleared a lot of the catchment areas and all of the soil that eroded out of those hills had to go somewhere, and where it went was into the Aldinga wash pool. So it's probably shallower than it was. But at the same time, those shallow clays may have sealed it a little bit more from the sea. So when the big high tides come, the seepage through the shingle ridge at the sea may not be as much. So it may even be a little bit fresher now. We don't know. There are ways that we can look technically to have a look. We can do diatom cores and what have you. One of the obvious things is to listen to the Ghana people very carefully to see if their stories can tell us something about the way it was, if their experience could tell us something about the way it was. But I was asked to come and talk about water bugs, not about butterflies.
Invertebrates.
Whole different kettle of fish. You'll get me back for the butterflies. You've got other people here to talk about the vegetation and about the bird life. I'm here to talk about the water bugs, the stuff that the bird life's eating. And I can see that you're all looking at the picture, very puzzled. No water bugs in sight? Absolutely not one, is there? That's because this is the cyanobacterial mat that's growing on the bottom of your wetland. It's made up of blue-green algae, filamentous types like this, and then they can fix nitrogen from the air, and then their slime that they excrete from their bodies has nitrogen in it, and then other things can come and live on that slime, so you get little diatoms and that growing on the surface, and then before you know where you were, water bugs have invaded it and are busy eating it, and then in behind them come the birds. So this is a really important feature of your area. It makes the soil suitable for those salt marshes to grow, and at the same time it is the primary production that's driving all of the tucker cycles in that wetland. So I came down for a visit in the middle of summer when it's meant to be dry, and there was water. Not a lot of water, just a little bit of water remaining south of Button Road. Was a little bit salty, not a lot salty. If you tasted it, you could just taste the salt. This tells us that it was probably around about 3 parts per 1,000, 3 grams per litre. If you can taste it, that's what it is. So I took a piece home with me anyway to put the conductivity meter in it just to make sure, and it was between 3 and 4 grams per litre, as you'd expect. So I only have summer records of what's found in the wash pool because it was summer when I came. I went to Duna's website to have a look. It was highly unhelpful. Apparently the only macroinvertebrates ever recorded in the wash pool are scuds and Adaphnia. Clearly the wash pool requires some further visits. I found 4 different crustaceans and 8 different aquatic insects in the tiny, tiny puddles that were remaining on the 16th of January. My field notes are here at that side table. Feel free to take a copy if you want to. Now, what we found was a little water flea belonging to the Daphnia group. This one's called Moina. It's a lovely little name. It's one of the smaller ones. This is a cyclops. This is a calanoid cyclops, a predator that's almost microscopic, smaller than a pinhead, and it's a great hunter. There were seed shrimps, ostracods, and there were, strangely, Salt Lake slaters, Haloniscus, normally only ever found in salt lakes, except in South Australia where you find it in the Coorong, and obviously in the Aldinga wash pool. How wonderful is that? The species that I found all prefer still water. They're not the kind of crustaceans that you find when the water's galloping around. They're tolerant of at least a small amount of salinity, and in the case of the slater, they're tolerant of a lot of salinity. The Moina is a scraper. It actually tends to scrape its food off the surface of plants and rocks and things like that. The Cyclops actively hunts down protozoans that are smaller than it, and if you think that's small, when you start to get right down to protozoans, you're in big time microscope country. The ostracod, the little seed shrimp down the bottom, that's a filter gatherer. It's actually a shrimp, but it actually filters, even though it looks like a shell. And these slaters are shredders, and they shred large pieces of vegetation. We didn't find any scuds. But there you go. Here's one I collected earlier. And maybe if I come back in winter, we'll find some scuds. Now, crustaceans are really interesting. And one of the reasons they're really interesting is because some crustaceans only occur in the kinds of wetlands where you don't get fish. And I don't know if you get fish in the Aldinga wash pool. There wasn't any when I came to visit, but that doesn't mean to say there aren't any.
They're only in the channel between the weir and the ocean.
Very important thing to know whether a wetland gets fish or not, because these particular creatures don't live where there's fish. These are special crustaceans that live in ephemeral wetlands that fish can't get into. And I don't know if you get them here, but you might. This is a clam shrimp. Lynceus tatii is its fancy name. It's about as big as a lentil in real life, and it lives in the parafilled pools. Considerably larger is this, often called a tadpole shrimp. I have one in a bottle over there. They can get quite big. Once again, this one's found at parafilled in the vernal pools, but you also find them in freshwater clay pans right through the Mallee. And then as you go north into South Australia, you get a different species. You've got 2 species of these in South Australia, and lots of people I know have never seen them, even though as a kid I thought they were as common as mud, you know, but they're not anymore. And this is a Para-Artemia. Some of you might recall sea monkeys. They used to sell on the back of the comics. We have several native species, probably 14 or maybe even 15 native species in Australia of Para-Artemia, and this is Para-Artemia zeitziana, and it's found in the Coorong, and it's found in saline lagoons all up the coast towards Port Augusta. And we also get another species that you get like over on the Eyre Peninsula called Longicordata, which is found in the Proper Bay coastal lagoon over there. So these are the kinds of things that you might want to go and have a look for in winter to see if we have them here. Now, we've also found aquatic insects. There were unbelievable quantities of these. Basically, backswimmers and coryxids were the dominant species that were present. There were also quite a lot of these. These are Ephemeral, the brine fly larvae. But as well, we found a few of the soldier flies and some magnificent hunting diving beetles, Alodesis, and the larvae of a water scavenger beetle as well, and even some magnificent damselfly larvae. Once again, really interesting because they feed on different parts of the wetland. So the brine fly larvae feeds on the benthic mat, on that cyanobacterial mat that feeds directly on it. This soldier fly here, he's a gathering collector and he eats decaying organic matter and microalgae. So he's almost like a detritivore. These guys are hunters. That's him as a baby. This is what he turns into. And the water scavenger beetle is another detrital feeder. There were lots and lots of things that I might have found that I didn't find that are likely to be present in the wetland come winter. One of the most popular with kids are the walking sticks or caddisfly larvae. After you use your net and you empty your samples into the nice white sorting tray, you sit back and wait for a while because everything's in a state of shock. And they kind of, all the little creatures go, oh my goodness, and then they wait for a little while and then they start to move. And kids will scream when they first see the first stick starting to walk along. And they'll go, there's walking sticks, there's walking sticks. And there are. They're caddisflies. Not all caddisflies live in stick houses. Some of them live in houses that are made out of pieces of stone, and others, like this one, makes a little tiny fine silk purse, which he dropped when I collected him. So they're quite different. And the different types of walking sticks actually eat different things. So the caddisflies that live in sticks are shredders, and they shred vegetation up, which is what you'd expect. Whereas these little guys down here is a filtering collector. He collects all the rubbish that falls to the bottom of the pond. So he tends to sit in his little silk purse and just wait for things to land on top of him. There are others that are predators. This up here, these are mayfly larvae, and we get numerous different types of mayfly larvae in coastal lagoons. A lot of them are remarkably salinity tolerant. Most of them eat detritus, so they're collectors. And this is a chironomid midge. That's one of the non-biting midges. Now flies are interesting. There's lots of different types of true flies. So mosquitoes are true flies, and non-biting midges are true flies, and crane flies are true flies. And I've only got 5, and I'm not going to let you have any questions. And so there's all different. You can expect a great variety once you start to hunt around. The other thing that we didn't find much in the way of were worms, molluscs and mites. Most of those live down on the mat, and I didn't really want to destroy what was left of the small amount of mat that was under the water, so I didn't go churning it all up. But I brought with me over the side, and you'll be able to have a look at during afternoon tea, heaps of bottles full of the things that you'll find in the mud. So grab a magnifying glass, haul a bottle up, have a look at them. You get an awful lot of these wonderful flatworms in most of these wetlands. You get quite a lot of molluscs, both gastropods and bivalves. And I did actually catch some empty salt lake snail shells. Another Coxiella, it's another one that lives in mostly salt lakes. So why would you go water bugging? Basically it's fun, hey? It also tells you a lot about the health of the area that you're looking at. And there are some great resources that people can grab hold of for either very little money or no money. And you can take your kids down and go netting with a copy of the Waterbug book or the free Waterbug app that you can get for your phone. Identify what you've caught, put the little darlings back in the water, and then at the back of both of these, each of the things you've caught has a score called a signal score, and that will allow you to examine your wetland and how healthy it is. It tells you about whether things are salinity tolerant, pollution tolerant, whether they're super sensitive, whether they like flowing water, wonderful things like that. For example, my summer collection was notable for having lots and lots of salinity tolerant species in it, including a couple of salt lake specialists. So, basically, thank you very much for your patience in listening to me. I didn't go in as a government person, so I didn't have access to government databases. I just went looking in all the places that a normal person would go and have a look. Yeah, you can do that very easily, and lots of people on their phones have software like Eco Maps, which is what I use, which allows you to record what you found, where you found it, when you found it, and all the rest of it. Yeah. Don't forget, people, if you find something and you want it to be easily accessible to the public, I would recommend that you record your finding in the Atlas of Living Australia. It's free, it doesn't cost you anything. Join up, sign up, put your records in. That makes it a lot easier for other people to use it. Yeah, I just came down for a visit because Peter asked me to come and have a quick look at it when there was some water in it. And basically the species that I got were salinity tolerant. Yeah. Yeah. There weren't any specific, the pollution tolerant ones, yeah, but they were all tolerant of harsh living conditions. Yeah. Okay. Yeah.